the Voyager 1 spacecraft, which currently possesses the distinction of being the farthest object made by humans, has captivated people all over the world for nearly decades. Voyager 1 has been dispatched since it communicated vital information from the outermost reaches of space and time, enhancing human understanding of the cosmos. Yet, the probe's recent strange broadcasts have included irregularities that have bewildered experts. These cryptic signals have sparked heated debates, leading the scientific community to ponder whether these anomalies are simply hardware glitches or evidence of something far more remarkable, possibly even extraterrestrial origins. Join us. We examine these baffling messages and probe what might lie hidden in the vastness of space. Our primal human desire to solve mysteries has long propelled the pursuit of space exploration. This awe-inspiring curiosity led to initiatives such as Pioneer 10 and Pioneer 11, among the most audacious space endeavors during their time. On August 20, 1977, the deployment of Voyager 2 from NASA's Kennedy Space Center was a sign of a revolutionary epoch in space study. Soon after, on September 5, 1977, Voyager 1 was launched, embarking on an expedition that would take it to the outer planets, dramatically shifting its course and scientific objectives. Each probe, approximately 721 kilograms, similar to a small family car, journeyed in unique directions at various speeds. On December 15, 1977, Voyager 1 achieved a major milestone by overtaking its sibling in terms of distance traveled, owing to their diverging trajectories. Since then, Voyager 1 has been an important instrument in expanding our awareness of space, yielding discoveries that have changed our perception of the universe. Before going any further, let's discuss recent groundbreaking outcomes. Look back at some of its earlier pivotal achievements. In 1979, positioned roughly 265 million kilometers away from Earth, Voyager 1 took high-resolution pictures of Jupiter. That year, in January, it had conducted an extraordinary 100 hours of observation that culminated in a time-lapse sequence that illustrated the rotation of Jupiter. This collection of 3,750 photographs delivered unmatched insights into the planet's tumultuous atmosphere and intricate details. During that mission, Voyager 1 also detected a ring around Jupiter and discovered 2 previously undiscovered moons, significantly enriching our understanding of the gas giant's complex system. To stay on course and avoid a collision with one of Saturn's moons, Titan, the probe carried out a number of navigational tweaks. Thereafter, the mission shifted focus beyond the solar planets and systems, redirecting the vehicles to travel through interstellar space, cruising at an impressive speed of 325 million miles annually. In January 1990, Voyager 1 began its mission to survey interstellar space, continuing its journey beyond the limits of our solar system. During this stage, it performed a number of amazing feats, such as identifying for additional moons Mamas, Enceladus, Tethys, and Rhiannon, capturing some of the most stunning images of the solar system's outer edges. On February 14, 1990, approximately 6 billion kilometers away from the Sun, Voyager 1 shot the iconic family portrait, a panoramic set of images of the inner planets. This 60-image array was appended to the probe's vast collection, which had already included hundreds of images from its close encounters with the gas giants. Voyager 2, meanwhile, accomplished remarkable feats on its own journey. At Neptune, it measured wind speeds reaching over 2,100 kilometers per hour, around 1,300 meters per second, the fastest atmospheric winds ever recorded in our solar system. It also observed Triton, Neptune's largest moon, where temperatures plunged to a frigid minus 391 degrees Fahrenheit, minus 235 degrees Celsius, making it one of the coldest known places. Triton displayed signs of icy eruptions, spewing nitrogen gas and frozen debris up to 5 kilometers high, exposing captivating new insights into its surface-level activity. These exceptional revelations significantly increased understanding of the diverse and dynamic conditions outside the solar system's domains. The contributions of Voyager 1 and Voyager 2 have been genuinely transformative. Their observations revealed previously hidden traits of satellites of Jupiter and Saturn, once thought to be dormant. This fresh evidence revamped theories about their geological dynamism. Voyager 2, especially, hushed history, by remaining the only spacecraft to this day to pass close to both Uranus and Neptune, one-of-a-kind achievement. NASA implemented inventive tactics to prolong the lifespans of these groundbreaking missions, like shutting down non-essential systems to conserve energy. The campaign is expected to remain active until 2030, announcing the conclusion of an extraordinary chapter for the teams dedicated to this mission. Voyager 1 and Voyager 2's construction exemplified cutting-edge engineering. These probes, designed for gradual rotation, minimized motion blur in their imagery while in transit. Even before arriving at the outer planets, the spacecraft started sending out intricate images of Jupiter that showed its swirling clouds and the iconic Great Red Spot, a huge storm that has piqued interest for decades. A one-of-a-kind discovery was the detection of active volcanoes on Jupiter's moon, Io. The instruments aboard the probes recorded unusual readings, later corroborated by images of enormous plumes of volcanic activity and a new surface. One outburst on Io was discovered to be 1,000 times stronger than Mount St. Helens, covering an area nearly as big as France. As both spacecraft continued their odysseys, they were gradually powered down to use less fuel before entering interstellar space. Notably, they didn't photograph Mercury or Mars due to technical restrictions. NASA later launched other notable missions, such as Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Voyager 1 overtook Pioneer 10 to become the most distant probe from Earth. Yet, Voyager 1 journeyed onward for another 14 years before officially entering interstellar space on August 25, 2012. A key factor in the success of these missions was the artful utilization of gravitational slingshot maneuvers, which raised the spacecraft's speed in their direction while conserving fuel. Rather than relying solely on propulsion engines, they leveraged planetary gravity to increase speed and alter course. This strategy allowed them to cover great distances with little fuel. As Voyager 1 neared Jupiter, the planet's enormous gravity accelerated the probe. To avoid dangerous deviations in speed or trajectory, accuracy was essential. These were aided by gravity boosts, which helped the probes navigate the solar system effectively. Voyager 2 also exploited gravitational pulls from Saturn and Jupiter to propel itself toward Uranus and Neptune, demonstrating the efficacy of this navigation technique. Looking back at these extraordinary endeavors, the scientific community eagerly awaits further revelations from Voyager 1's anomalous signals. The remaining spacecraft, operational far beyond the known bounds of our solar system, are investigating the enigmas of planets like Jupiter, Saturn, Neptune, and Uranus. Voyager 1's observations were vividly documented by time-lapse films, capturing eruptions on Jupiter and revealing new satellites, as well as a previously unobserved ring encircling the planet. These findings greatly enriched our understanding of the Jovian system. In a similar vein, Voyager 1 discovered 4 more moons orbiting Saturn: Mimas, Enceladus, Tethys, and Rhea, while delivering stunning visuals of the planet and its rings, showcasing their intricate structures. The mission's expeditions to Uranus and Neptune made important observations about their atmospheres and moons, bolstering our familiarity with the solar system's remote regions. After completing their planetary flybys, both probes charted a path toward interstellar space, where they continue to send invaluable scientific data. This ongoing investigation increases our understanding of what lies beyond the vicinity of the stars. As we anticipate updates regarding Voyager 1's bizarre transmissions and their consequences for our cosmic understanding, these extraordinary missions continue to inspire scientists and enthusiasts worldwide. Their achievements remain foundational in advancing human understanding and pushing the cutting edge of space research. Programs like Voyager have provided unprecedented glimpses of our solar system far beyond its bounds, delivering iconic imagery and vital scientific data beyond their empirical knowledge legacy. A sign is carried by the spacecraft, a treasure, a message representing Earth to any extraterrestrial civilizations. The golden record has greetings written in 55 languages, musical compositions from diverse cultures, and natural sounds like thunder and whale vocalizations. This interstellar communication stands as humanity's hopeful appeal to intelligent life beyond our planet. Voyager 1 and 2 carried a suite of scientific instruments that significantly broadened our understanding of space. These included magnetometers, plasma wave detectors, and imaging sensors, all furnishing essential data about space environments. The magnetometers decoded the magnetic fields of Uranus, Jupiter, Saturn, and Neptune, showing how they interact with their surroundings. Plasma wave instruments clarified the impact of solar winds on planetary atmospheres. A highlight of the mission was charting the heliosphere's outermost boundary, an enormous region influenced by sunlight particles and electromagnetic fields encompassing the solar system. Voyager 1 approached this frontier. It observed a shift from solar wind to the interstellar medium, providing essential insights into how Earth is protected from cosmic rays. The spacecraft pinpointed a zone known as the termination shock, where solar winds are compressed and slow. Beyond it lies the heliosphere, a turbulent layer where solar and interstellar particles collide, creating a dynamic environment. The voyage of Voyager 2 also significantly enhanced our understanding of the outer solar system. Its close encounters with the giant planets yielded key observations, particularly regarding the discovered magnetic field of Uranus, which was tilted in an unexpected fashion that defied theoretical models. These additional revelations have sparked investigations into planetary magnetism. Not only did these missions advance scientific understanding, but they also reignited public enthusiasm for space travel. The spellbinding images of remote planets and the enthralling narratives of these missions have inspired countless individuals from different generations. Iconic visuals, such as Saturn's graceful rings and Jupiter's volcanic moons, have become emblematic, motivating future scientists and explorers. As Voyager continues to transmit extraordinary information, its extended venture into interstellar realms offers unparalleled opportunities to decipher the essence of the universe. Despite past explorations of the planets and solar system, the space between stars has revealed unexpected complexities. Regions once thought to be barren now exhibit elaborate phenomena that defy current scientific paradigms. Among the most enthralling discoveries is the finding of cosmic rays from beyond our solar system. These ultra-energetic particles, traveling nearly at light speed, offer clues about processes in remote areas of our galaxy. By examining their energy and composition, scientists aim to better understand the workings of distant stellar nurseries and galactic dynamics. Additionally, as Voyager 1 and 2 venture deeper into interstellar space, their onboard instruments keep measuring the speed and density of the sparse matter, the interstellar medium that fills the space between stars. This substance, made of gas and dust, interacts with solar wind and shapes the heliosphere's structure. As the probes navigate it, they share priceless data that help researchers model how energy and matter behave across cosmic expanses. Additionally, the Voyager missions have revealed essential information about magnetic fields in interstellar space, illuminating their characteristics and influences. These findings could eventually foster advancements in our knowledge of magnetism in the galaxy. The current exploration of these far-off regions enhances not only our scientific insight, but also motivates succeeding generations of astrophysicists and engineers. The unforgettable shots captured by Voyager, most notably the famed pale blue dot showing Earth from more than 6 billion kilometers away, serve as a sobering reminder of our minuscule place in the cosmos. These images, along with the missions, scientific milestones, have profoundly altered our perspective on our planet and its position in the universe. The Voyager mission's success has cleared the path for even more ambitious expeditions. Thanks to the technological advances forged during their missions, utilizing advanced probes to even more distant corners of our galaxy is increasingly within reach. Aspirations like examining exoplanets, identifying potentially habitable worlds, and even trips across galaxies are consistently moving beyond visionary ideals to attainable goals in the future of cosmic exploration.